to Solving for the Undefined podcast. I'm your host, Johanna, founder of Miss Kuiper's Classroom, the place that equips teachers in creating a healthy math classroom where students can thrive, no matter their academic abilities. But it's not always about the numbers, and that's why I'm here, bringing you the formulas to solve your problems, math and otherwise, plus strategies on cultivating that necessary math mindset. And that's what you can count on. Hello, welcome to a brand new episode. I'm super excited for today's episode because it's the first Monday of the month and therefore the first ever Breaking Down a Concept episode. Because it's the initial one, after listening, make sure you let me know what you liked, what you didn't like, what suggestions you have, etc. I want this to be the best experience for you. In today's Breaking Down a Concept episode, we are going to be talking about solving equations. I chose this as the first one that I'm ever doing because when I think of starting the school year, my mind always goes to solving equations. My first few years of teaching, that's how we always started, solving equations. It was good review, plus it was easy to build on for 8th grade math. During my first year, I remember we handed out these green packets, maybe 3 or 4 double-sided pages that started out with combining like terms, distributive property, and then moved into 1-step, 2-step, and then multi-step equations. And it just gradually built on itself. And I was so excited about this packet. I was like, it's scaffolding. We'll really get to see where students are at, what they can do. I was just super excited for this. But I noticed something when it came to the students working through solving equations. They were struggling with the basic 1-step equations. Now this is where there's one operation like x plus 4 equals 10. They knew how to use inverse operations, like what you do to one side, you do to the other. But the foundational actual understanding of what the equation was saying was not there. I watched the specific student, a top performing student, work through 4 plus x equals 10. I watched them incorrectly add 4 to both sides, showing that x equals 14. And then I paused the student and asked, why did you add 4 to both sides? To which they replied that they needed to use inverse operations to solve for x. And my response was, true, but let's look at the problem. Does x equal 14 make sense? And for the record, as a new teacher, my questioning process was not the best. But I was trying my best to help the student see that 14 was not the correct answer without telling him it was not the correct answer. But the student didn't know how to respond to my question of, does 14 make sense? 10 plus 4 was 14, so x had to be 14, right? And this is a problem I saw with a lot of students, not just my top performing student in that class. So that's when the fire and mission of solving equations with true understanding became a passion of mine in the classroom. So today, I'm going to break down how I teach solving equations so that my students can truly learn and understand what it means to solve for x. Some things to note, I teach 8th grade math, where the standard is to solve linear equations with rational number coefficients, including equations whose solutions require expanding expressions using distributive property and collecting like terms. But I always go back and start with the basics and move forward. If you're teaching a younger grade, your timeline might look different than mine, and you might spend more time in a certain area and not even cover some of the other things that I do. But the ideas will still work for you. Now, I don't do this in one day. This is something I spread out given my class periods or students' understanding over a week or 2 weeks, really dependent on the students themselves. So let's jump into the basics. No matter where my students seem to be, I always start at the basics, meaning some understanding of what x truly means. So I remove the x and replace it with a blank. So an example would be 3 plus blank equals 15. and we would work through how do we figure out what goes in the blank. And I would use a line of questioning like, what goes in the blank? And they would say 12. And we would talk about how do we know that 12 is the thing that goes in the blank? Well, students would say because 3 plus 12 equals 15. Awesome. So why does 12 belong in that blank? And this is a question that usually gets some weird looks because they're like, didn't we just answer this? But why does 12 belong in the blank? Because both sides need to be 15. To that I ask, why do both sides have to be 15? Because it says so. That equal sign declares it to be true. Both sides have to be 15. That's why 12 goes in that blank, because 3 and 12 make 15, making that statement true. Our goal when filling that blank is we are striving to help the equation be whole by finding that missing puzzle piece. And for that equation, 12 is the missing puzzle piece that declares the statement to be true. Anything else would make a liar of our statement, and math doesn't take any liars. So, now that we've covered some basic understanding, I usually tie it into a real-world connection because remember, we have to make math meaningful, relevant, and relatable. And there's a lot of connections that you can make to the idea of balancing something, but the one that I like to use is lifting weights, specifically a barbell. We used this one worksheet one year where it was a monkey holding a barbell over his head. And so that's where I think the idea for me came from. So when you're lifting a barbell, you need to make sure both sides have the same amount of weight. Otherwise, it's going to be uneven and it could tilt and it would hurt you. So for an example, if you're going up to do a deadlift, so that's where you stand and you pull from the ground. If you were to put 45s on each side, when you lift up, it would be even, it would be balanced. But if you're adding like a 5 and you don't add one to the other side, when you lift up, it's going to be tilted. So what you do to one side of the barbell, you have to do to the other. And when students have this idea of what you do to one side, you do the other, it gives them a visual for what that equal sign truly is. You need both sides to be balanced in order for it to be true. Otherwise, things are going to get messy. So once they have that understanding, then we move into looking at one-step equations or one-operation equations. So before we, as a class, start talking about inverse operations, we try to solve equations using what I call the intuition method. I saw this on a TED Talk a couple years ago, and for the life of me, I cannot find it anywhere. But it was a math-specific a math-specific TED Talk where this presenter is talking about how students aren't fully understanding the concept of solving equations because they don't understand what it means on both sides. So that's where the intuition method comes from. So it's very similar to like the 3 plus blank equals 15, but with a variable instead of the blank. I feel like it leads into a more natural understanding of inverse operations in the long run and why inverse operation helps solve for the value of the variable. So here's how I would walk students through understanding one-step equations using the intuition method. So on the screen or on my whiteboard, I would put a seesaw looking scale thing. One side has the expression x plus 5, while the other has the number 8. Then I ask the question, what would the value of x have to be to keep it balanced? And I remind them again about the barbell. Both sides have to be equal. And then I give them some private think time. And then after a little bit, I'll have them turn to their AB partner to chat. And if you don't know what an AB partner is, it's usually the person sitting right next to them. I sit my students in pairs of 2. Pair, 2, I think those are the same thing. I have them sitting with a partner. And one of them's A and one of them's B. It just allows for a little bit more direction. Like saying, partner A, you're going to do this part. Partner B, you're going to do this part. Then you'll turn and talk about it. So for this problem, I would give them some private think time so they have their own time to contemplate it. and then have them an opportunity to turn and talk with their partner. Once we have determined as a class that 3 would keep it balanced, I asked if it would still be balanced if the x plus 5 and the 8 switch sides, and why. This just helps them solidify the thought that 2 sides are equivalent and therefore interchangeable. It doesn't mean that one number has to be on one side of the equal sign. They are equivalent and therefore interchangeable. And then I usually do this with a similar example using subtraction, so students again get to see that balancing of things. So say the example is x minus 7 equals 19. What would keep this balanced? Usually with the subtraction problem, I see 2 answers emerge, either 26 or 12. Or if no one says 12, I bring it back up asking, why is the value of x not 12? This provides the opportunity for us to talk about checking our work by taking that number that we found and plugging it back in to see if the sentence or the mathematical sentence, equation, whatever you want to call it, is actually true. So if I took 26 and plugged it back in for x, does 26 minus 7 equal 19? And then I would do the same thing for 12. Does 12 minus 7 give us 19? And then they would see, oh, 26 is the actual answer because 26 minus 7 equals 19. Now, if you are working with students who have some number sense trouble, this might be a little bit of a struggle for them up front. But I always have students use a calculator because calculators are a tool to help us. And so then they can kind of guess and check a little bit to figure it out. Now, I know guess and check isn't the best method out there, but it is a way for them to do this. So after we've talked about the intuition method part of it, I pose this question. What if we are unsure of what x is? Then I have the students turn and talk, discuss with a partner. And I love to see the creativity that some of the students come up with, the creative ways that they are thinking about it. One year, I had a student suggest of using a number line to count 7 spaces from 19. That's like genius. I love when students use those kind of tools. And another one was the guess and check method using a calculator. And then typically one student usually brings up the idea of inverse operations by saying, oh, we could add 7 to 19 to find what the value of x is. And while this one specifically helps us lead into the discussion of inverse operations, it is important to validate all the responses. I think this is something a lot of teachers struggle with. Not everyone, but some teachers struggle with, is the idea that math is a creative subject. It's creative in the sense that there's not just one way to do things. Yes, there's typically one answer to a problem, but the journey to get to that answer is up to personal interpretation. And this might be calling some people out, but it's typically an older generation who was taught one way or the highway in school when it came to math. This is how you add. This is how you subtract. This is how you divide. That kind of struggles with this idea that there's more than one way to do it. Now, it's different if you're talking about a specific algorithm to use, like, hey, we want to use a squared plus b squared equals c squared for this particular problem. But overall, there's more than one way to do things. And that's a conversation I have with my students. I'm going to teach you multiple ways to go about solving for the value of x. Sometimes I will ask you to use a certain method that we've learned about, but most of the time you get the freedom to choose whichever method works best for you. And I also tell them sometimes their parents or their grown-ups might have a different view of how to do it, and that's okay. Again, math is creative and everyone can use a different way and it will all lead to the same answer, but it's okay to be creative with the process. And so with this creative process, we make a list on the board naming each way or method that we've learned so far, or using the ones that students have mentioned earlier. So this whole process leads us into talking about inverse operations. So again, the earlier example I used was x minus 7 equals 19. So we know something minus 7 equals 19, but we aren't sure what. So we need to be able to move some things around to help us figure out what x is. To do this, we want to isolate the variable. And we have a conversation about what isolate means, turn and talk with a partner, figure that out. Then I ask, what do we need to move to isolate the x? And students usually respond with 7, which is semi-correct. We want to attend to precision. I believe that's mathematical practice 6. Don't quote me on that, but that's what my brain's remembering. So we need to get rid of the -7. And what we need to do is we need to make it into nothing. We want to be a magician. So we talk about what number represents nothing. 0. So how do we make this -7 into 0? What do we need to do? And I know that this line of questioning may seem long and drawn out, but this line of questioning is essential from moving students from following a list of directions into actually understanding why inverse operations work. Then once we have the conclusion of we have to add 7 to both sides, we bring it back to the lifting weight scenario. If I add 7 pounds to one side, what do I have to add to the other? 7 pounds. Equal signs are all about balance. And then that brings us to the conclusion that x equals 26 because 19 plus 7 gives us 26. Now, if the equation involves multiplication or division, it's a similar process. So let's talk about 7x equals 28. First, we want to break it down so students know that 7 and x are being multiplied together. I think that's one of the ones I see my students specifically struggle with the most, not understanding that the 7 and x, when they're sitting next to each other, are being multiplied. So I talk about how addition, subtraction, and division all show their sign. So like the plus sign, the minus sign, fraction bar, division sign. But multiplication is sometimes, quote unquote, shy and doesn't show its sign. So you can also bring up that 7 and x are 7 x's being added together. Multiplication is repeated addition. So the equation is telling me that 7 x's together make 28. But I need to know what 1x equals. So this tells me I need to divide. I need to divide into our equal groups to figure out how many is in each group. So I want to divide 7 by 7 to make one group or figure out what 1x equals. And then again, what I do to one side, I do the other. So if I'm dividing 7x by 7, I also need to divide 28 by 7, which leads us to the conclusion that the value of x is 4. Now, we've talked about intuition method using inverse operations, and there are other methods I teach as well, such as algebra tiles and the hanger method, but because those are so visual, it would be hard for me to explain. So I will link videos in the show notes on my website so you can watch how they work. And they're very similar between them, algebra tiles and hanger method. They're just different representations of very similar things. So that's pretty much it for solving one-step or one-operation equations. So the next level of solving equations is two-step or two-operation equations. Now this process is very similar to that of one-step equations, but we're adding on one more thing or one more operation in order to find what the value of x is, or the value of the variable if you don't want to use x. So let's take 2x plus 8 equals 14, for example. Again, I want to start with the idea of intuition method because I think it really does help students best understand what the equation is, quote unquote, saying before using some rote techniques of look at the sign, what does it say, or what's the opposite of that? Because I want them to truly understand it so that way they know why they're using those inverse operations. So first, when we have a two-operation equation, we want to break it down. And the first step in that is ignoring the 2x. So thinking of ignoring the 2x, what plus 8 gives us 14? Well, 6 plus 8 equals 14. Now that I know that 6 plus 8 is 14, I know that that 2x that we ignored earlier has to equal 6. So, because of that 2 and that x are being multiplied, remember multiplication is shy, it doesn't show its sign, I know that 2 times something gives me that 6. And I can use a multiplication table, I can use a calculator, or maybe I just know that 2 times 3 gives me 6. So I know that x equals 3. And then we always talk about plugging it back in and doing the mathematical operations to double check our work. So 2 times 3 gives me 6. 6 plus 8 is 14. 14 equals 14. My equation is balanced. Equal signs are all about balance. So boom, 3 is the correct answer. And you can do more examples with using division, subtraction, fractions, negative numbers, decimals, to really hammer that idea in. But usually after the conversation about one-step equations we had previously, I find that most students get the hang of it pretty quickly and don't need to do that many practice problems as a class before working independently or working with a partner. Now, one thing to note, and maybe I should have mentioned this earlier, but I try to use only quote-unquote nice numbers when we're starting out. Meaning, I want to make sure that we're using numbers that create a whole number answer. And the reason I do this is to help, again, students truly grasp what the equation is saying and what the value of x has to be. So when students are having trouble with number sense, decimals tend to make things even more challenging, and I don't want to create any more barriers for students accessing that knowledge to become independent learners. So by starting with nice numbers, I am better ensuring the success of my students in understanding the concept of solving equations before making it complicated. And then I tell my students up front that their answer should be a whole number, kind of a way of self-checking as they're going through, especially as they start getting into multiplication, division, in those kind of two-step operation equations. And then when it comes time to add in the complexity of decimals, I let them know ahead of time that a decimal answer is a possibility. That way there's no surprises, no extra stress or anxiety about getting a whole number answer. And I usually don't add in those decimals until I feel like they're semi-solid in the inverse operations part, because that's usually when they start to see those decimal answers. So let's chat about inverse operations with two operation equations. Using the equation 2x plus 8 equals 14 again, what happens if we are unsure of what plus 8 gives us 14? This is where we get out our magician skills or detective skills to isolate that variable to figure out what its value is. So to do that, first thing we need to move is what? We need to move the plus 8. Again, attending to that precision of the operation sign going with the number. And it's easiest to move because it isn't attached to the variable. See that 2 and that x, those things are attached, and it's going to take a different operation than just removing that plus 8. And you can explain to your students later why mathematically we have to move that plus 8 first, but I don't typically add that in now. So to move that plus 8, we need to make it into nothing. This is our magician skill. So what number represents nothing? 0. So how do we make our plus 8 into 0? What do we need to do? Again, this line of questioning is essential for moving students from following a list of directions into actually understanding how inverse operations work. So to make a plus 8 into nothing or into 0, we have to subtract 8. And again, you can have this turn and talk or as a full class. This is not me presenting information, although it might sound like it because it's weird for me. I'm going back between visualizing myself teaching it to trying to explain it. And so I feel like I'm having two different voices here as I go through. Maybe you can't detect it, but I feel myself going between those two places. So we need to subtract 8. What we do to one side, we have to do to the other. Equal signs are all about balance. So once we take away that 8 from both sides, that leaves us with 2x equals 6. Now, if we're unsure here, what do we need to do? This is telling us that 2 x's make 6. So we need to figure out what 1x makes. So we need to divide. And by dividing by 2, that will show us what 1x equals. And again, what we do to one side, we do the other. Equal signs are all about balance. You might be beginning to notice that I'm repeating the same several lines over and over again, and that's on purpose. It takes on average about 7 times hearing or seeing something for people to be able to take action on it. It's called the rule of 7, typically used for marketing, but I find it to be true for students as well. But by repeating that same line with what I'm doing, it can help solidify the process and why we're doing something to solve for the value of x. So taking what I'm saying and what I'm doing and combining them together, so later on when students are independently working, they can hear my voice in their head. It's all diabolical, I promise. Not really, that was a joke. And that's pretty much it for solving two-step equations. Now I also show my students how to use algebra tiles and hanger method for two-step equations. Now for me, hanger method is something that I learned recently, so for me, hanger method kind of falls apart after two-step equations, sometimes after one-step equations, honestly. But it's still a tool that students are able to use and figure out for themselves. And like I said earlier, algebra tiles and hanger method have very similar rules for how they're used, just slightly different representations. And again, because they're visual and hands-on, it's really hard for me to explain. And so I won't be walking through them in today's podcast episode. But usually after teaching two-step equations, I use this online game called Solve Me Mobiles to help students practice the balancing technique. It's not a real direct translation between equations, but it has the essence of it in there, the idea of balancing. So I will link that in the show notes as well. So if you haven't tried it yet, you should definitely check it out. All right, and the last thing that we're going to talk about today is multi-step equations. Now, when it comes to multi-step equations, a couple different things pop in my mind because there's so many facets and levels of steps that you can add to an equation. So there's distributive property, combining like terms, variables on both sides, etc. Now, because distributive property and combining like terms are something I usually teach before going into equations, I'm not going to be talking about those today. But I do have a blog post coming out this week talking on how I teach those. So, when I think of multi-step equations and what I'm going to be talking about today is when I have variables on both sides of the equal sign, like 4x minus 10 equals 2x plus 6. Now, I absolutely love using algebra tiles for working with multi-step equations, specifically for those who have variables on them both sides. And the reason why, if you know something about algebra tiles, is because of that balancing piece. If I have 4x tiles on one side of the equal sign and 2x tiles on the other, I can take 2x tiles away from both sides. Because they both have it, I can take it away. It's very similar to the idea of what I do to one side, I do to the other, but in a minusing kind of way, if that makes sense. But algebra tiles is only one method that we can use to solve variables on both sides of the equal sign. So another way that I found recently is called the box method. And I got this idea from, let's see if I get it right, Idea Galaxy Teacher. I love their blog. They have such amazing things. But they talk about this idea of the box method. And really, it's just a way to organize the inverse operation piece of it because there's many things going on when it comes to solving for the value of x with this type of problem. But the graphic organizer lover in me loves this method. So it's the primary way I teach when it comes to solving multi-step equations. So it is, again, a very visual thing, but I will do my best to walk you through it because this way is phenomenal. So I want you to visualize in your mind, close your eyes and visualize. Unless you're driving, then don't close your eyes. 4x minus 10 equals 2x plus 6. The first thing students are going to do are draw two boxes, one on each side of the equal sign. And then we're going to divide it into three parts. But the way we're going to divide it is draw a horizontal line down the middle. And in the top portion of that box, divide it in half with a vertical line. So kind of like two boxes on top, one longer box on the bottom. And do that for both sides. Now here I like to use highlighters or colors or something to help us kind of visualize where things are going to go. So I like to take our variables and underline them with, say, the color blue. And then I'm going to take my numerical value. I'm blanking on the word for a number that doesn't have a variable, but the number without the variable, I'm going to underline in a different color, say yellow. So now I have those two different pieces, and they're going to be traveling to separate boxes. So I'm combining the like terms across the equal sign. So for the example I'm going to give you, I'm going to move the variables to the left side and the numerical values to the right side. So I'm going to take those two variable terms, there we go, terms that we underline in blue, and draw arrows to the box on the left side, the two top boxes in our box. And then I'm going to take the numerical values or the number terms and take those, we underline them in yellow, and draw arrows to the box on the right side. And then I'm going to move them there. But if the term crosses the line, you have to change the sign. And that's just the cute little saying that we use to talk about the inverse operations piece. If something is crossing the line, it has to change its sign because we want to make it into nothing. The way we make it into nothing is by doing the inverse of it. So for that minus 10, I'm going to be adding 10. And this is just a streamlined process. And then once students have organized the pieces, so the variable terms on one side, numerical terms on the other, and if they've crossed the line, they've changed the sign, then students get to combine the x's and put that number into the larger box on the bottom. And then they do the same thing to simplify the numerical term on the other side. And then finally, we're left with, let's see if I can do the math in my head, 2x equals 16. I think I did that right. So now it's again talking about we have two x's equaling 16, but I need to figure out what one x equals. So then I need to divide by 2. So what I do to one side, I do to the other because equal signs are all about balance. So when I divide 16 by 2, I get 8. So the value of x equals 8. This is just another way to organize the idea of doing two sets of inverse operations and then solving for the value of x. And then in the end, students write x equals 8. They can justify their work by showing that 8 is the value by plugging it back in for both x's. But there's the idea of the box method. Now, I know this is a very visual method, especially if you've never seen it done before. So I have a video of someone else doing it. I will post it in the show notes on my blog, so that way you can see the process that they go through, which is very similar to what I just said. Now, one more thing to add about using the box method. I like students to do the arrows the both directions. So what I mean by this is we did 4x minus 10 equals 2x plus 6. We took the variables and moved them to the left side and the numerical terms and moved them to the right side. So this is where those AB partners come back in. I have partner A do it one way, and then I have partner B do it the other way. So the variable terms come to the right side, and the numerical terms come to the left side. And then I have them compare their work. Does it really change which direction you did it? No, it doesn't. So that's another way for them to see that it really doesn't matter if you move things to the left or the right, as long as you use that inverse operation technique or your magician skills to make it into nothing. You can do it however you want. And that, my friend, brings us to the end of our first ever Breaking Down a Concept episode. So I hope this was helpful breaking down how I would scaffold solving equations. I know it was a lot going from the basics to multi-step equations, and hopefully you were able to take something from today, especially if you don't teach 8th grade math like I do. And with that, if you have questions or when you come across a question, feel free to reach out. You can find me on Instagram or you can email me. Please reach out, and I am more than happy to be a thought partner with you as you walk through maybe some new ideas of how you can work with solving equations. And when you have a chance, in the show notes on my blog, I will have linked for you videos on how you do some of these methods. And they're not of me, so maybe someone else sharing how they do it will spark some more ideas in you. So I believe I have a video on the box method, hanger method, and then I have the link for Solve Me Mobiles, the blog post on how Idea Galaxy Teacher does box method and multi-step equations in general, as well as I have 2 reels showcasing how I use box method and intuition method. And lastly, as a treat for you, I will be posting the slides that I use in my classroom that you can take and modify how you want to. So if you need to see how I do it, or you need to visualize the things that I've been saying, you're more than welcome to take that and use it how you will for your classroom. Thank you so much for being here today, and I will calc you later. Thank you so much for tuning into today's episode. To find all the links and resources to things talked about in this episode, head on over to MissKuipersClassroom.com and click on podcast.